Oh, okay. Hello everyone. It's 9 on the dot, and today we have to be really fast because we need to close early. I realized that we don't close early on these live streams, right? So a good evening to you, Cosmo. Good evening to you, Musa. Ensure. Good evening. Good evening to all of you. Am I audible? Can you hear me clearly? Am I audible? I think I am. So today we are going to be talking about uh, bash scripting. We need to take some time to look at the terminal, how the terminal actually works, and for you to have that mastery, that control of the terminal as well. Because the terminal is like the like I used to say, it's like the powerhouse of of what we do as software engineers. You know, many a times you see those elite programmers writing code, and you see their terminal getting all crazy, and and it makes beginners feel like programming is difficult, whereas it's not. Programming is really easy, really easy. All you have to do is understand the fundamentals very well. Like I said, that's why the WinMingle community is the best place for you to learn. We ensure that you have good fundamentals, and then we let you into the world for you to go, you know, go learn, go upgrade your skill. That's the best way to learn, because all programming languages are actually built on the same fundamentals, the exact same fundamentals. If you're if you have a strong mastery of the fundamentals of 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 one programming language, you should be able to apply it on the new language. Anyways, without saying much, because we need to close early, our live streams are getting like 2 hours long, and I want it to be for 1 hour. So we need to start now. So bash scripting, right? That's what we are here to talk about. Like I told you, as a part of the WinMingle community, I hope that you enjoy all the benefits that's associated with the WinMingle ecosystem. It's very important that you benefit. I know that some of you would have noticed by now that your consistency score is a little bit strict now, right? I'll soon start giving out the handing out my scholarships again, like I do. I like making sure that people grow and people learn, but then I I I would allow a few you know days to pass before I start doing that again. So for now, we'll be talking about you know bash scripting. This is what differentiates beginners from amateurs. Bash scripting. You know, amateurs depend on the IDs. VS Code, Atom. There are a lot of them. So some people still use Notepad. That's really funny. you know. But some people still actually use Notepad plus plus till now to learn. It happens. I know most of you will not know what it is because we are teaching you the right way. We are teaching you deployment. We are teaching you DevOps engineering, system engineering. You'll be so comfortable to work in the terminal by the time you're done with this training. And it's a very big plus. There are a few different fields that you could work in the software engineering company. You could work as a front-end engineer. Your role could be the role of a back-end engineer. You could be a DevOps systems engineer, to be handling deployment. You could be a QA, a quality assurance engineer as well. We have people that, are really good at programming as well. What they do is to sit on the front end and do testing, you know, and they are paid really well. Like when I say well, very well, they are paid very well for testing. So there are a few roles that you could bag as a software engineer, and one of the greatest advantage that you would have as a software engineer is being a full stack engineer, being able to deploy platforms to work on the server. You know, this is what the WinMingle community structure hands to you on a platter. We ensure that you're comfortable working with the terminal, very comfortable. Anyways, that's what we'll be talking about. Let's start now. Let's go straight into our terminal. Let me set up the terminal. Here's my terminal. So can you guys see my terminal? Is it clear enough? Can you see my terminal, and is it clear enough? Yeah. Is my terminal clear enough? So yeah, being a full stack engineer is trust me, is the best thing that can happen to you being a full stack engineer, right? Because as a full stack engineer, you can fit in anywhere, just about anywhere. It's just like me looking for a software engineering job. I did something recently, and I was like, let me find out what AI thinks about my proficiency, because I've been working a lot, and my AIs, they know that I've been doing a lot of stuff. And then I asked AI, I was like, okay, somebody's saying if I can zoom into it a little bit. I can. I was like, hey, if I want to get a job, like a new job right now, how long will it take me to get a new job, right? And AI was like, not long, uh, maybe 2 weeks, considering your current level of experience in software engineering, your vast front end, back end deployments, you know, it's another level. So can you guys see my screen? It's, I'm increasing this stuff, but it feels like it's not increasing on your end. Is it better now? Does my terminal look good? Is it better? So can you see my screen? Okay. Somebody is saying it's okay, it's clear now. So we can start. I can start typing on it. Oh, okay. Yeah, I think it's clear. I think I have a device in front of me, so I can see my screen as well. Right. All right. So let's start by the basics of what bash scripting is, right? So bash scripting, we could literally divide it into three different parts. You know, the first part would be shell navigation. You know, the second part would be permissions and redirections. Then we will now talk about bash scripting for utility programs. You could actually build utility programs on your computer that run without any any coding, any programming language. So basically, one thing you need to know, if you're working on a low level program, let's say you're building uh, a a smartwatch, as the case may be, you would not have enough. The problem with building smartwatches is, or you're working on, let's say, Raspberry. Somebody asked me here one time if I could teach him how to install a program on Raspberry Pi. I could actually do that. And the problem, one of the basic problems that you'll be having when you're working on small devices like this is that you would have space constraints. There's going to be like a memory constraint. You are restricted to working with a little bit of memory, so you cannot really save a lot. So imagine working on building on a program at a very low level, and you've got only but a few MB to work on, right? You don't have the space to install all the dependencies that Python comes with, so you cannot actually write Python code, but then you still need it to solve certain problems. You still need to. This is where Bash is so nice. Like Bash scripting is the hallmark of Linux, of the Linux kernel. It's very important that you understand it as a software engineer, else you'll not be able to function in some situations. So basically, the way I work, I literally work on the cloud. I save things to GitHub like I've taught you guys, and I save to other places that anywhere I want to save my stuff. But I literally do not have anything on my computer hardware, right? Which is to say that if I am to come to your house today, you watching me now, if I'm to come to your house, I could function with your PC, with any PC that you give to me. I could literally do my entire job, right? Without my computers. So I have two computers here in front of me. I have a MacBook Pro and I have a Windows computer. I could use any one of them that I want to without um, without trying to move things from one place to other or to another or something. I could even leave these two computers here and go somewhere else and still function very well. Why can I do that? I can do that because I work in the terminal many a times. I'm so good at this terminal thing. It's very important. Like when you see all these senior engineers, you guys, they usually show them on movies as they act as hackers or stuff like that, or they work with FBI to uncover cases and track criminals and all of that. You guys will be learning a lot. If you keep living on the bash, you'll be discovering a lot of things, right? And then you would understand cybersecurity much before you even start taking any cybersecurity course. you know. So what we are saying is Bash is very important. You can manage memory and still solve complex programs like utility programs that would actually help you, you know, build whatever you want to build on your small computer that you have or small device or small all you need is an operating system to run on the device, and then maybe you have one kind of port that you can connect to a keyboard and see a terminal, and you're good to go. You can build and deploy an entire platform from whatever kind of device that is at your disposal. That's why you need to learn bash scripting, so you understand at least anytime you have a Linux operating system, you understand how to use it, right? So uh somebody is shouting yes, low memory. That's the problem, with small when it comes to all these smaller devices like watches and all of that. You need to know how to manage data. You need to know how to work in the terminal. Else, you cannot work for certain companies as a software engineer, right? So that's what we are going to be talking about. I'm going to keep it start really basic and start opening your eyes, towards at the end of this bash scripting course, we are going to build a full utility program. I don't know what we are going to build. I'm going to think about it. Maybe something we use to track. I don't know if a lot of you are crypto people here. We'll build something we can use to crack and track the current price of cryptocurrency at all times. So imagine you have an investment and you want to always know what the price of a particular cryptocurrency is, let's say Bitcoin itself or any other coin tied to the blockchain, as the case may be. We are going to build something that we use in tracking it. Or we could maybe build one of these regular simple projects too, or you can even still build the tool. I'm down, I'm up for it. We are not going to be using any fancy programming language. It's not going to be Python, it's not going to be C, it's not going to be any other language that you're thinking about. It's going to be shell scripting, only bash, right? We'll be working in the terminal for everything. Somebody is saying you are backing the stage camera. Yes, I'm not actually. Oh, I'm looking at my computer right now. I'm not trying to I'm supposed to be writing code as I'm not trying to talk to you. Okay, let's start working, right? We'll think about this camera placement later. Let's start working. So The very first thing that we would work on is we'll work on navigations first, right? I want you to understand the shell environment, the bash shell environment. Um, there are two types of paths. We've started learning, right? We've done a brief introduction to this topic. So there are two types of paths. There are absolute paths and relative paths. You know, some of you would have realized about absolute paths and relative paths by now. By the time you get to your third project, I know a lot of you on this training, you guys are still struggling with project one and two. By the time you get to your third project where you have to build a full stack application, you would realize that you need to get a full understanding of absolute and relative paths. I'm going to teach that here now. So for an absolute path, you are giving us the full directory from the beginning to the end. Imagine you have a folder in your you created a folder in your user. So you know when you from your C drive, you go to users. From your users, you pick a particular user, let's say Greenfield, and from user you pick a particular folder. Inside that folder, you have another folder. You have to give us the entire chain of directories till you get to the exact file from the root directory, right? That's an absolute path. But for a relative path, you're giving us the you are describing the path from the standpoint of the current documents where we are. So basically, you're like, for a relative path, you're like, okay, in we are in, let's say, learn bash scripting directory, and we want to go to bash directory. And bash directory is the directory before learn bash scripting. You are just telling us, okay, from learn bash scripting, go back once, and you get to bash directory, right? So that's what a relative path is. You're telling us the path in relation to the current path where we are working right now. That's what a relative. So that's the difference between absolute and relative paths. So a typical absolute path would look something like this. Something like let's say home slash users slash greenfield slash bash slash bash tutorial bash underscore tutorials. So this is like a typical absolute path. We are starting from the beginning of the whole, and we are like naming everything out to the end of it. While a relative path for bash is dot dot slash. You know, we are. Oh, I'm going to explain what dot dot slash is. So some of you might have not learned this. So as we go on, let's go on. We are going to explain the two of them with examples, right? Um, that's what it feels like. It feels like dot dot slash the current position, the current file where we are. It tells us, oh, we are going one step backward. That's how relative paths are. We are describing the path from where we are. Essential things that you need to understand in essential things that you need to understand when it comes to shell navigation is you need to know what a dot is. You need to know what this dot dot is. You need to know what, I don't know what this sign is. I'm going to ask you guys the name. Okay, let me just start teaching you. So if you do something like cd is change directory, right? Cd dot, it means current directory, the current directory we are in, one dot. You see, it doesn't change it. We are still in live class bash tutorial. We are still in the current directory where we are. If we are to say cd dot dot, it's taking us one directory back. It's taking us into live class. So dot dot, like I said, slash the current path we are is like we are relating this live class directory in relation to the current uh, directory where we were. That was what I meant when I was talking about relative paths, right? And now we can still go back to say cd batch underscore tutorials. So we are back to where we were. And then if we want to go to the home, there's this sign. I don't know what it is. This sign here that is waving. Some of these things, I don't really know the name of this sign. Anybody that knows the name of this sign should put it in the comment section, because some of these things we just learned it and we as well don't even know what we learned. It's funny, really. It's really funny. So if you know the name of this sign, then you put it in the comment section for me to learn as well. Yeah, so cd this sign, that's funny, will take us to the home directory, right? So if we do that, you see it's taking us to our home. It's removing everything. This is our home directory, right? And then if you want to go back to the former directory you were working in, you were working in a directory and you jumped to some other location using an absolute path or a relative path or whatever path, and you want to go back at once. You want to go back without plenty having to write plenty lines of code. All you have to do is cd hyphen, right? Cd space hyphen. If I hit the enter button, you will see I'm skipping I'm skipping live class and bash, a lot of typing. This is taking a lot of typing away from my work, and I'm skipping all the way to the last point I was before I went to my home, right? So somebody said the sign is, come on, abbreviation sign. It's called an abbreviation sign. The other one said it's called a tilde. Okay, I don't know. Somebody is saying it's tilde. The other one is saying it's tilde. The other one is saying it's abbreviation sign. Okay, we will find out after the class. I'm going to go browse it as well because I know this stuff, but I don't know the name. Anyways, live classes, bash tutorial. We are back to the directory we were without having to type too much lines of code. Okay, somebody is still saying it's tilde. Another person is saying it's tilde. Oh, okay, okay, that's fine. Thank you guys for teaching me something today. I as well have learned something. It's not only you people that will be learning. When you stop learning, you start dying. So I as well, I learn a lot. I was telling you guys, I asked my AI if I could get a job, like what kind of role and what companies. And AI was like, hey, apply. You get a job in 2 weeks. Just keep applying. Sometimes this AI is really funny. It does not know the current situation of our country. It thinks we are in the US. You get a job in like 2 weeks if you apply for a job. You have so much experience, show them your portfolio and all of that. Anyways, leave AI alone. AI needs to understand that this is Nigeria, this is not the US. It does not come easy. And that's why I encourage all of you, instead of trying to get jobs, get competent and build the job for yourself. It's the best thing that you can do for yourself. Get competent, build the job for yourself. All right. Um, yeah. So that's that for relative and absolute parts, and that's that for how to move around using the change directory, right? Um, Usually the first thing we learn when you know, we work on the terminal, the first thing we teach people is about how to locate the current working directory, right? And that's PWD. That's the first thing we usually talk about when you work in the terminal, how to know the current working directory. The next important thing is, yeah, that reminds me, if your current working directory was to be like something that includes a symbolic link, you know, sometimes these links are not being printed. They don't show and all that. You need to add like a dash L, right? So currently we are not in a symbolic link. when you ever create one, you can add a dash L here to view, right? I know you guys know what symbolic links are. I've taught that in the training. If you're not a part of the training yet, go start your class. It's very important, right? So the next thing we should talk about extensively is how we list files. Remember, I kept telling you guys, I've been telling you guys a lot. When it comes to bash scripting, it is these little things that make up for the advanced things, right? So, like I said, we are going to build, we are trying to, our time is fast spent. We might have to learn bash for 2 weeks, this week and next week. But then we have to build two major projects in bash scripting before we move on. So I just show you how bash scripting works, how you use your computer to, set up utility programs that could help you do whatever you want to do. The concepts for building these things will still remain the same, regardless of the uh, regardless of the what do you call it, the language you're writing. We are either Bash, C, Python. We are going to be learning. I'm going to bring in, after teaching you guys C and Python on live streams like this, I'm going to start bringing in other languages, so you see how I relate what you already know, what we've taught you in the WinMingle training, to the new languages. You now see how similar they are, and then you know that you are able to write any other language on your own. A lot of people ask me, will I be able to write another language that we are not teaching? Are we going to learn this language and that? And I'm like, don't worry, when we are done teaching, take your training seriously. When we are done teaching you, you would realize that there's nothing like uh, will a new language be difficult to learn? New languages are so easy. You just need good fundamentals. There's nothing in writing a new language. All there is syntax difference. And the syntax difference are usually not much. It's just a little difference here and there. Hey, this language, stop putting semicolon here and there. Maybe in C, when you're the libraries you're importing. Imagine in C, you guys used to import standard IO, so you can print out something. You can use like the print F. But if you're writing like let's say Go, you're writing Go. Which of you know the Go language? There's a new language called Go. If you're writing Go, Go was created I think sometime in 2007. If you're writing Go language, the file you're to import is not a standard IO. It's called FMT. If you import FMT, you can now be uh, calling the print statements and all of that. It's little differences. It's not anything much, you know. You just need to learn syntax and then you're good to go. The conventions that we are teaching you here will still remain the same. That's why you need to build them. Some of you find building the printf project really difficult. Make sure you understand it. If you're not able to build it, go back and take your training. Go back to all your structures, go back to functions, structures, how you import models and all of that into your file. And by the time you're done with all of this, you understand how to, arrays work and all of that in C. Buffering, when you understand buffering as well, you understand pointers, you should be able to do your printf project. That's all you need, right? So that's that for that. Let's keep going. Let's keep going. Just know that all you need to be a success is right in front of you. All that you need, every single thing that you need to be a success in software engineering is right in front of you. The WinMingle community is offering it to you on a platter. All right. So the next command that we should learn and learn a few flags to be using is the ls command, list files, right? So ls is how we list files and directories. And it has a few flags that we are going to work on, that we are going to learn and fully understand how to use the ls command. So yes, what does the ls do? Ls prints out files and directories if you want to print all the files and directories in this location, oh, currently we don't have files and directories. So let's create some files and directories. So let's say we'll create one file, file one, right? .txt. Let's create txt files in this. Currently, there's nothing in this directory. So we've created file one is a txt file, and let's create file two, touch file two, file two. So I'm using touch, like to create the files, right? And I think we should put something inside the files. Let's cut something into the files. I'm going to explain all of this. Um, if we cut something into the file, I'll tell you what this sign is, what it does very soon, and why it behaves the way it behaves. File one, let's cut something into file one. And what we want to say, this is file, okay, this is the first file, right? And then, oh, I pressed clear, so sorry, I was supposed to create control done, but it's fine, something should be there. Let's cut something into file two as well. This is the second file, right? All right, so we are back. We had a little bit of technical challenges, and we had to resolve them. Don't worry, very soon our live streams will not have interruptions. They are much better than how they were when we started. But there's still something I need to fix in this new office of mine. I have this new office prepared where I'm streaming from. Without saying much, let's work. Let's go to the business of today because we've spent a lot of time uh, trying to set up. Can you see my screen clearly? Let me open. Where's this stuff? So CD live classes, and we're in bash underscore tutorials. Hopefully you could see my screen much clearly. Okay. All right. So where did we stop? I think we stopped at LS. I was trying to talk about how LS works when we stopped. Let me see what you guys are saying about my screen. It's zoomed in enough now. It's good enough for me to start teaching. All right. So we were talking about LS, right? And coming. Let me set up. Sorry guys, I'm trying to set up fully. All right, so I'm done. I can see that you guys can see my screen very well, so I will just start talking, right? So we're creating some files, right? We created file 1 and file 2. Let's create a directory. So to create a directory, make directory. Uh, let's use a dash p so we could create uh, a few more directories. Or don't worry, I'll teach that separately so you understand that. Let's create a directory and say this is dir1, and we'll make another one, make directory dir2, right? So we have two files and two directories in our current working directory. I need to be seeing you guys as I talk, and I need to be seeing what you are saying. All right. I need to be seeing what you guys are saying. Oh, okay. I have that figured out now. Okay, so we currently have two files and two directories in our current working directory. And what do we want to do about these two files and two directories that we have? We want to use them to learn a few flags, right? So you understand how to manipulate the computer, especially using this ls. This ls command is very important. So the first thing you want to know is long listing, right? You want to know how to do a long list. No, okay. The network is really unstable, and it has not been fair to us in this class. All right. Let's see what we can do. Let's see how fast. I'll try to rush everything I'm doing to ensure that we we learn something today, regardless of this bad network that we are having. Uh, all right. I hope you guys can hear me. Let me check if I can hear myself. Okay, so we are good to go. let's um let's go further and really fast, right? So we are talking about ls, right? And for ls, when we do ls on the screen, I told you about the information that is being displayed. We have the file type, the permission type. I'll teach you about these permissions, how they come about. I'll teach this the user accessing it. This is the amount of storage assigned to the files, right? And like you can see, it's storing in bytes. It's showing how many bytes are assigned to this particular file and folder. And then you could see here it's storing the time. All right, so we are back. We are back, and let's work as fast as possible for the people that is due on for me. A 5G here. All right, so I think we are back because the network is now a little bit stable. All right, hope you guys are there, Chilex and the rest of them. Hope you guys are there so you don't draw me back. So like I said, ls, when you're using commands, you need to know the flags. It's the flags that make the commands more powerful, right? So let's go. Where's my terminal? Come on, why is this happening to me today? Yeah, so I'm live. I want to be watching this stuff live so I can know if this network is stable or not. All right. So we've created a few files. Like I said, ls, let's clear the screen so nobody gets confused. So like I said, ls lists all files and subdirectories in our current directory. These are subdirectories. Directories in our directory is in our current directory is called a subdirectory, right? So ls lists all files and subdirectories in our, the files are these ones in blue. The directories are the ones in blue. The files are in white, right? And if you want to see them in a long format, let's clear the screen. We can say ls-l to see them in a long format. So in the long format, this flag is called long. You know, it shows more information about the files and subdirectories in our current directory. And this first part here shows the permission. As you can see, uh, this is giving both read, write, and execute permission. This one is giving only execution and writing permission, and this one is giving only execution permission. Now, there are a few things that you need to know about the permissions that you're seeing on the screen. Anyways, okay, I'll teach that separately. I'll teach about permissions separately, but just know that I'll teach about the read write so you understand how they are calculated and how they are being given. I'll teach it when I'm teaching ch mode. There's another uh, command called ch mode. We've not gotten there yet, so we are still talking about ls. So this one shows more information about the current directory, all the files and subdirectories in current directory. And then the next one you'd want to know is dash a. So if we do ls dash a, you're going to see all hidden files. So you see these dots, dot, dot. There are certain files that we want to hide. We don't want people to see them. Do you understand? We want them hidden. Those files will not show on the screen. Let's say, so ls, we just created a file called test.txt. We just created a test.txt file and we did ls. And you can see that ls is not showing us the text.txt file amongst the files that are shown here. I'm teaching you guys. These are the little things you need to know about the terminal and how cyber security. These little details that you need to understand. So you understand cyber security from before you start your cyber security training. After the software engineering, we are going to be teaching you a whole lot. We'll teach you deployments. We'll teach you how to compile applications. Currently, in your software engineering training, we are teaching you how to build uh, web applications. Right? We'll teach you how to compile them into applications, and then we'll also point you in the direction you should learn to build applications from the ground up, you know, to build a full stack application and all of that. We'll do all of that with you guys. We are learning live, right, on these live streams. Now, uh you can see that this test.txt file that I just created is not showing here. Even if I let's clear the screen and I list all the files in long format, it still does not show our text.txt file. The only way we can see it is if we use a dash a, right? So if you say ls dash a, you can see the test.txt file. And why is this file hidden? Because we added a dot before the file. So if you add a dot before creating a file, the file is going to be hidden, right? That's how to create a hidden file. You want to create a file, you don't want other people to see. This is how to create a hidden file. So you want to save things on your computer and you don't want people to access it. You want to be the only one accessing it. Yeah, you can do this, and permission as well. I'll teach you guys how to play with permissions when we get to ch mode. So you'll be the only one that can access things on your computer. There are certain people can access and all of that. Anyways, um uh let's go. I'll teach you about how to give yourself, how to give a certain group permission, or how to give a particular user permission that is not the root user. Okay. So basically that's what dash a does, right? On ls. If you do ls dash a, it's going to show you all files, all hidden files in the current file. So you can actually do ls dash la as well. Sorry, I did ls dash ls dash la, right? So in a long format is also going to show the hidden file, right? So the hidden file was created, it has not been given any storage, it does not contain anything, right? So let's go further. There are a few more flags. There is, yeah, so currently if you do ls-l in long format, you're going to see that the sizes, the sizes here are written in bytes, right? If you want to change it to human readable format, you'd want to say ls dash h, right? So let's still put this in long form. So ls dash lh. As we can see, it's now telling us that, okay, this is 29 bytes, this is 27 bytes, and this is 4 kilobytes. This is 4 kilobytes, right? The directories were given 4 kilobytes and all of that. So in total, you know, It's saying we have 16 kilobytes in this directory, right? So that's that for dash H. It's like putting the size. It's making you understand what size it is. You know, it's displaying the human readable sizes as part of the information about the files and subdirectories in this directory, right? Um, the next thing that we will talk about is uh, okay, let's sort. We could actually sort by time, right? If we sort, it's going to show the newest files, the files with the highest. So let's do that. Let's do that. Let's say ls dash lt, right? So if we do ls dash lt, you're seeing that it shows directories first, right? So you're seeing directory 2 is now coming before directory 1. Before it was directory 1 before directory 2, but right now it's directory 2 before directory 1, and then it will go to the files and still list file 2 before file 1, right? This is what it means to sort by time. So ls dash long, we are showing all the informations about it and we are sorting it by time, right? That's what we are doing. Let's clear the screen so people will not be confused. You know, we programmers, we like our screens to be very busy, you know, to be like all that. I like my screen to be all that. Anyways, I'm clearing it for now for everybody here to understand what's going on. So yes, we could as well sort by the reverse order. We could do the oldest file to see the oldest files, you know, before we see the new files. We could do that as well, and that should be dash r, I guess. ls dash l r, right? Sorry, I didn't add a dash there. So dash lr, yeah. So yeah, so you can see in long formats, the last file we created was file 2. It was created 932. Second to the last file was created 931, and the other one, the last directory we created was 1003, and as the case may be, you can clearly see that we are now doing this in reverse order. The last file we created was file 2, file 1, and all of that, and directories as well. So that's what it means to list in this order. We are like sorting things by time and in reverse order as well. And as well, we could still list stuff recursively, right? So we could list all subdirectories and their contents. So if let's see, our subdirectories does not have contents right now, right? So let's put something in directory 1 and directory 2. What can we do? Let's copy the content in file 1 and let's move it to directory 1 as well. We could do copy the content in file 2 and move it to directory 2, right? So I'm going to teach you guys about copying. Don't worry, I'm not explaining that. I'm currently explaining ls for now. When I'm done, I'm going to start explaining how I'm copying when I start teaching you about copying. I just want you to have a strong mastery of how shell scripting works. For now, we are in shell navigation, right? So we could actually do list stuff recursively. So let's add uh, ls dash l r in caps, right? So if we do that, ls dash lr, you see that we still have a total of 16 kilobytes here in this entire page. And then it's listing recursively the content of the directories and the files as well. So you can see that in directory 1, we have file 1 and file 2 inside directory 1. Currently, in our current directory, which is the bash tutorial, we have directory 1, directory 2, file 1, file 2, and then it's still telling us that inside directory 1 here, there is file 1, and inside directory 2, there is file 2 as well. So that's uh, what it means to list stuff recursively, right? So let's clear this page and uh, what else? What else have we not talked about? We have not sort files by their sizes, right? Have we done that? I don't think we've done that. So that's by sizes is capital S. So ls dash l, and let's add an S to it. So if we should do that, you'd see that the bigger the size, the it's going to be sorted by the bigger size, right? So these two files have the same size. 29 is higher than 27 bytes, right? And that's why you see it the way it is right now. So the first two directories are same size. That's why they are at the top. The file 1 is of size 29 and file 7 is of size 27, right? File 2 is of size 27. So that's why it's the last one. Anyways, let's keep going. We have a lot to cover before. Let's clear our screen again. Yes. What else? What else? What else? So you've been seeing me adding these commands together, these flags together, right? So you could do something like ls dash lah. You know, you are by doing lah, you are listing all files in a long form, and you are including all uh, hidden files, and you are making sure that the sizes are in human readable format. So it's not going to just show bytes. If the size is up to a kilobyte, it's going to show it in kilobytes, right? That's what ls dash lah does. And let's go back. And what else? What else? Let's clear that. We could still do ls dash lth, you know, list. We could do ls dash lth. Pretty much everything that I've shown you today, you could use them. You could combine them anyhow that you like. You could combine them to get any kind of results that you want, or any kind of sorting that you want. You could see LTH is listing in a long format and is sorting by time, and is setting all bytes or all sizes to be in human readable format. As you can see, directory 2 was created 1028, directory 1 was created 1028, and file 2 was created 932. File 1 was created by 931. You could see that it's being sorted by time, right? So basically what I'm trying to say is that you could combine any um uh any of the flags that you want, anyhow that you want it, right? You could still sort by size. I just sort by time. So you could do ls dash lhs, capital S. So yeah, you could see we are sorting by size right now. Is everything with 4 kilobytes are up, and then 29, the files that have 29 bytes and 27 bytes are below, right? So that's that for that. We I've taught you guys so far. I've taught you guys what a dash l is, long format. When it comes to ls, I've taught you that a dash l is to list in long format. I've taught you about a dash a. Let's and I said a dash a is to list hidden files. I've taught you about dash h makes the time to be in human readable format. I've taught you about dash t, sorting by time. I've taught you about dash s, sorting by size and in recursive manner. That reminds me, the reverse order of sorting by time and size is different from sorting recursively, right? Reverse order is small r, recursively is big R, right? So that's that for that. We've talked about ls. we've spent a lot of time, so we have to move fast, right? The next thing that we should talk about, I remember telling you guys about changing directories, right? So cd is how we change directories. Let's go back. So cd is the command for changing directories. Cd change the directory, right? And I showed you guys that somebody said it was, oh, was it tilde, right? Was the cd tilde to go to the home directory? That was the name you guys gave me. And cd dot dot, cd space dot dot will take you back out of this directory, right? Cd space dot dot just took us back out of the directory. And then let's go back into the directory, cd bash tutorials. Yeah, so if we do cd dot dot slash dot dot, it will take us 2 steps back, you know, 2 steps upward out of the directory, right? So you could see it has taken me out of live classes and bash tutorials if I do this. And I also went further to tell you guys that if you want to jump back from anywhere that you jumped to where you were before, cd hyphen, right? It has taken us back to bash tutorials where we are supposed to be learning right now, right? So the next thing that we would want to do is let's cd to something far, right? So you guys can see, you could actually cd and use a var, a slash var, you know. This is like a slash var slash log, right? Let's say log. Let's see, log is in the var directory, right? So ls, you could see all our logs currently, right? We could actually do this in long form. This is ls-l. So you could see that the logs have things inside of them. You could see all the things are being measured in bytes. All the informations are in bytes. I told you the first thing to the left that you would see is the permission. The next thing is the user. You could see some things are like root user, some things are system log. So that this to tell you that system log is like the admin user part, all of that. Anyways, the next thing to the right is the size, and you could see here that the sizes are all in bytes because we didn't specify that it should be in human readable sizes. And then the next thing is the time before the name of the files. So if we wanted this to see the sizes in human readable formats, you know what to do. It's supposed to be ls-lh, right? You guys should be replying me as I keep asking questions in the comments. So you could see some things are like 38 kilobytes, some things are like 12 kilobytes and all of that, 42 kilobytes. There is no file up to like a megabyte here, else you'd see megabytes and gigabytes. Okay, so anyways, to go back, like I taught you guys earlier, to where we were is cd hyphen, and you can see it took us back to bash tutorial, cd space hyphen, and we are back to bash tutorials, right? So that's that about changing directories. The next thing that is very important, if you've learned how to change directory, you should as well know how to make a directory, right? So the way we make directories, right, is mkdir, like make directory, mkdir new dir. So ls, you can see that we just made a new directory called new dir, and the mkdir as well has what do they call it, flags as well, that makes using it very easy, right? And one of the major flags that software engineers use is the p, the dash p, the dash p flag, right? And what does this dash p do? Dash p enables us to make a directory and make another directory in the directory that we are currently making. So if we want to do a dash p, we could do something like mkdir dash p, and then we could make all the subdirectories in the directory that we are creating. So we could make a directory slash a subdirectory one, a subdirectory one slash a subdirectory two. So what this does is it makes directory, it makes a subdirectory inside directory, and it makes subdirectory two inside subdirectory one. And we could keep going on and on, adding subdirectory three till you get tired of adding directories, right? Or till you do what you achieve what you want. So basically, you could see that we have the directory that we just created at the beginning, directory, and we could actually cd into it, cd into directory, and you could see ls that we have subdirectory one. If we cd into subdirectory one, you could see that we have ls subdirectory two. And then somebody is saying, I'm getting you well. Yes, you should. I'm glad that you're getting me very well. And then I don't know if we created subdirectory 3 inside subdirectory 2. Oh, we did. I can see it on the screen. So you could keep opening it, but I would want to go back, right? And continue teaching, right? So that's that for mkdir with using a P. For P, we make subdirectories inside subdirectories in the directory that we are creating, right? And you could actually make a directory in a verbose mode as well. When you are making directories, you can actually do this in verbose mode. And this by adding a P to it. What it means to do stuff in verbose mode is you want the computer to be verbal about this stuff. You want it to tell you, hey, you've created some directories. These are the directories that you created. So how do we do that? Let's say new directory 2, right? So mkdir-p new directory 2, and we want to say subdirectory 1 in it and subdirectory 2 inside inside subdirectory 1. And like I said, we want to do this in verbose mode. So we want to add a v, the flag v to the dash p, right? And you can see that it's telling us that the computer is telling us that it's created new directory 2, and inside new directory 2 it created new directory subdirectory 1, and inside subdirectory 1 it created subdirectory 2, right? The computer is printing out to the screen what it has done. That's what it means to print in verbose mode. Sometimes you want to see the information that this computer is actually doing this. There's this concept of piping where you take the output of a particular command and you put it in something else. So sometimes you want to like log what you've done to a file, right? So you can see that your code is running. If you were to be running this in a bash script and you wanted to achieve something, you want to log it. So you can be reading your log files and be seeing, oh, at this point, my code created these files, and these files will be used to save this and that. You would maybe want to save logs where you keep track. I created a crypto trading bot at some point, and as the bot was trading, I had a log file I was using to register information. I was using to check, what the bot was doing, right? That project was in Python. Anyways, the same thing could happen here in bash scripting. So let's go further with it. So you could see in verbose mode, the computer is telling us everything that the computer has done. I'm still here. I'll teach you the concept of piping, where you take output of a command and you feed the output of a command to another command. We are still here tonight. We have a lot to learn. Remember, I said we'll build two major projects in bash in the shell, right? And then you guys will understand how the shell works, and you can take it up from there. You could go increase your knowledge. Like I can't teach you everything, but I can teach you enough to ensure that you are a strong person, you're a strong developer, right? That's basically what I'm going to do. So there is another one for another flag. Hope you guys know how these flags are coming about. If we take the man documentation of the mkdir, you would see that, does it not have? Yeah, it has. So if you take the mkdir, the man documentation of the mkdir, you see all the flags. So I just taught you guys about dash p, dash v. I'm not, yeah, dash m shows you the mode, the current mode. So you could actually set who can access your file as you are creating your file, you know. let's quit and let me show you dash m. Dash m, you set the permission, the file permission of your file while creating the file, right? So we could give the root user read write and read write and execute permission. We could give the group only read and execute permission, and we could do the same to any external user as well. So for us to do that, to give permission, we will have to say mkdir directory with permission, and mkdir the flag, right? We forgot to put the flag dash m. So if we do that, oh come on, it's saying it's complaining. What's it complaining for? Oh, the reason why it's complaining is we did not write the permission. So we've written dash m. The next thing we want to do is we want to give the root user 7 and remaining people want to give them 5. I'll tell you about how I calculated this 7 and 5, right? I'm going to teach you guys when I get to ch mode. So let's press enter and see if it still complains. If it still complains, then okay, so it's not complaining anymore. You could see that it now understands. If we print this in long form, uh, directory with permission, let's say ls -l -l. So you could see in the right here in the middle, we have directory with permission. You can see the permission at the beginning of the file that it has d arrow. Let me highlight it. You can see these are permission here, right? You could see that it is drw. This is read write and execute permission for root user, and then we are giving only read and write permission here and execution permission here, right, for the group and external users. So that's the permission stuff. We decided the permission that we are going to give. I'm going to teach you guys more. You would understand how to determine the permission, the exact permission that you want your file to have while creating the file. Okay, and I will teach you in ch mode. I'm getting there, but we have to take it one step after the other. All right, can you guys hear me? Hope people are still here learning. um what else, what have I not taught you guys? Okay, I taught you guys, somebody might ask, with dash p you were able to create subdirectories inside subdirectories and so on, but somebody might want to create like 3 different files, 3 different directories inside the same directory, like 3 different subdirectories inside the same directory. Remember, dash p was only making us to create a directory inside another one, like the way we did when we ls. What did we use? I think we used new directory 2, and we were able to create subdirectory 1 and subdirectory 2 inside subdirectory 1. Okay, but you might want to be able to create like 3 new directories on this screen now, on this particular page where we are. And for you to do that, you need to understand another flag, and that one is -v, right? You might want to understand that to use -v is verbose, but you might want to understand how to put, you might all you need to do that, I think, is to put in a curly brace. Yeah, that's the right thing, in a curly brace. So let's use -v to print this in verbose mode, and let's do, you don't really have to do this in verbose mode anyways. So we could now create as many folders as we want, or directories as we want in this. Imagine you're starting out building, and you want a folder for your css files, you want another one for your javascript files, and you want another one for let's say log files, right? And hit enter. You could see that we created directories for css, js, and log. So let's do ls. You can see all of them on our screen right now. You can see css is the very first directory. You could see javascript and log towards the end before new directory. They are both here. So somebody is saying, I'm learning more, sir. Yes, so we have a lot to cover. There are a lot. If you want to work in a software engineering company, you need to have the software engineering values. And this is what it is, you know. You cannot be working in real time with a team of engineers and you are finding it difficult manipulating your computer. That's something else. So, anyways, uh, that's that for that. So, like I said, if you want to create all of these files on the screen at once, you need to put things in a curly brace, right? And they would all be created. So let's go for that. Um, we've been talking about how to create directories. I think the next thing to actually talk about is how we create files, right? Let's clear our screen. So to create a file, we use the touch command to create a file, right? And touch command to create a file. Um, can you guys hear me? So yes, to create a file, we use the touch command. I think you guys saw me using this to create the few files that we created before now. With touch command, you don't need to put things in curly braces to create files. You just need to space them out. So if you want to create 3 files here, you can create, let's say, index.html. I think we should clear off the screen. We have too many files here for you guys. Uh, what we should do? Okay, let's go into one of the directories so things don't get messy. Let's go into directory 1 ls. Well, we already have file 1 in directory 1. So we are in directory 1 right now. And in directory 1, we want to use touch file to create multiple files, right? We could simply do touch and we could say index.html and space, we could say style.css, and you could keep going as on and on as much as possible. All files will be created. So remember, that's the difference between make directory and touch. You could create everything for files the same time, but for directories, when you're using make directory, you need to create you need to put them in curly braces, right, and use a comma in between them. That's how you do it, right? You could actually change the time. You could actually, okay, when using touch, right, what touch does is it creates, an empty placeholder file if they do not exist, right? So if the file does not exist, touch is going to create it. If the file exists, touch is going to modify. Do you understand? The current file that exists, right? So a few flags could be used with the the touch command as well. So the first one that we want to test out is let's use a dash A. I think a dash A. We have dash A access time to modify access time. We have dash M, right? And we also have, let's see the touch command. I think dash C as well. Touch man touch. You know. So these are how you know the Linux. Yeah. So yes, we have dash A, right? To change only the access time. I think I talked about dash M and dash C. Yeah, so dash C, do not create any files. And where's dash M? Let's see. No dash M here. Why is there no dash M? I think I've used touch dash M before. So let's see what touch dash M does. touch dash m. This is not in the, let's see if it works on this computer. It actually works, right? ls dash l. So okay, it actually works, but I don't see what it does here. But I know that there used to be a dash m. Anyways, on my computer right now, my man documentation says touch does not use dash m. So we could leave that one. Anyways, you could basically use touch for creating multiple files, right? Let's leave touch at that. Touch is not a very serious command that we want to stress ourselves with. We basically could use touch for that. Anyways, let's go to copy. We have a few files. We might want to be copying files right now. Let's talk about copying. And for copying, we want to go back to where we have a lot of files so we can see things to copy around, right? Yeah. So to copy, the command for copying is cp, copy cp, right? This is the command for copying, and we still have a few flags for copying as well. We have dash r to copy recursively, right? So if you want to copy a folder that has different things in them, you really need to add a dash r. That's let's go look at it. So which of these folders have a lot? I think new directory has a lot in them. Let's see the content of new directory. cd new directory ls. Okay, new directory does not have stuff in it. So let's cd into new directory 2 and check if new directory 2 has stuff in it. ls. Okay, so new directory 2 has subdirectory 1, and in subdirectory 1 there's subdirectory 2, right? So we are going to use, to practice what cp is, we are going to use new directory 2 ls, right? So you could see that new directory 2 is here in our screen. So we want to copy it, new directory 2 into new directory 3. So let me first copy this without using the recursive flag, without telling it to do this recursively. So if we try copying new directory 2 without telling it to do this recursively into new directory 3, you would see that the computer will complain and it's telling you dash r not specified, omitting directory, or omitting directory, new directory 2, right? The computer is not able to do this recursively. What it means to do recursively is you solve a problem. I thought you guys what recursion is now. Oh, I have not taught you what recursion is. I think I'm teaching recursion in C and in Python, right? I don't know. Have you guys learned what recursions are? You know, you do things one after the other. That's what recursion is, till you get a certain result, till you get to the end, or till when the end is false. There's no more files anymore. That's what copying recursion is, recursively is. So if we add the cp-r to it, and we do this on new directory 2, right? And we copy it to new directory 3, right? It's not going to work. So if you check on your screen, you see that we now have new directory 2 and new directory 3. And if you check the content of new directory 3, is going to be the exact same content in new directory 2, which was subdirectories, right? So let's see cd new directory 3 ls. You'd see that it's subdirectory 1 that is there, which is same thing that was in new directory 2, right? So let's go back to where we were. Aside from copying recursively, we could actually copy in interactive mode, right? So you want the computer might want to ask you some questions. So you press OK if you want to you press yes if you want to copy, right? So if we copy new directory 3 into new directory 4, right? Let's copy new directory 3. We have to use dash r. right? And this time around, we need to add I. So let's say dash IR, because we want to do it in interactive mode. And we want to copy new directory 3 into new directory 4. What this would do, let's hit enter. What's that? There was no information. Hello, ls. New directory 4 was created, so I was not interactive mode. Is supposed to prompt. Oh, interactive mode. We were copying into new directory 4. Sorry, new directory 4 was not there before. So interactive mode would only work if the directory we are copying to has a content, right? So somebody is saying, as for me, I am still on C. I will like to know what recursive means. Oh, okay. I'm going to explain what recursive means. Anyways, before I go there, let me complete what this interactive mode feels like. So without the interactive mode, you could copy something in a directory to another directory that is not empty, right? So we could copy, let's see a directory that is not empty. Okay, file 1 and file 2. File 1 has a text in it and file 2 has a text in it. And the content of, let me show you guys, ls. So you see file 1 and cat file 1 and cat file 2. This is the best way for me to explain this. So you can see that file 1 has a different text from file 2, right? So if we want to copy the content of file 1 into file 2 without specifying the I interactive mode, it's not going to complain. It's just going to copy it silently and we lose the files in file 2. But then if we add dash I, we are not going to be losing the files in file 2 because it's going to ask us, are you sure you really want to copy before we copy it? So let's try that out. Let's say cp dash ir, we no longer need recursive mode because we are not copying the directory right now. So cp dash ir dash I file 1 into file 2, right? Into file 2. And then we get this question here. What this question is saying, do we want to overwrite file 2 with the content of file 1? You can now press yes or no, right? So if we press yes, the content of file 2 will now be the same content in file 1. So let's see cat 2, file 2. So you can see this was cat file 1 and this was the content in file 1 and that's still the content in file 2. So let's clear the screen and still change. File 1 is now file 2, so let's change the content in file 2 again so we can still do copy, test another copying pattern again. File 2, and let's change it updated to something like updated content, right? So we've changed the content in file 2, right? And then let me show you guys so you know. Cat file 1 and cat file 2, right? So you could see that we have separate different contents in file 1 and file 2, right? And we talked about interactive mode, right? So let's talk about copying things in verbose mode, right? Verbose mode, like I told you, verbose mode is like telling the computer to tell us what is copied, right? So that's dash v, you know. And let's clear the screen and let's copy something. Cp dash dash I want to use a directory, I want to use a directory, and I have directory, uh, new directory 4, right, into new directory 5. So you can see that in verbose mode is printing out that we are moving new directory 4, we are moving new directory 4 into new directory 5, and we are moving sub directory 1 that is in sub new directory 4 into sub directory 1 in new directory 5. And then we are as well copying subdirectory 2 that is in subdirectory 1 that is in subdirectory 4 into subdirectory 2 in subdirectory 1 in new directory 5, right? So that's what verbose mode does. Verbose mode copies out stuff. Dash R, like I said, is the flag for recursive. Yeah, so somebody asked me what recursive was. That person was, where is that? Somebody asked me what recursive, what it meant. He said he was still learning C, and what does it mean to copy something recursively. So what it means to copy recursively is to do one after the other. So like you can see that for the new directory 5, the computer copied new directory 4 into new directory 5, right? And then he went back to the subdirectory 1 that was in new directory 4 and copied into subdirectory 1, but this time in new directory 5, and he did the same thing. He kept doing the same thing till there was no other file to copy anymore or directory, right? So that's what it means to copy recursively. So you cannot copy folders or directories without being recursive, because they have things in them. They have other subdirectories and files in them. So you have to be recursive. So the computer will keep doing that, will keep copying one after the other till it copies to the end, right? That's what it means to be recursive. Go and do your recursion classes in C. It's very important. Recursion is very fun. It's really fun. You need it. It's so important for the people that would like to go into things like game development, or like to build crazy data structures and want to be sorting information anyhow they like. They would really like to, learn how recursion works. Anyways, that's that for verbose mode. We still have other uh, ones like, yeah, let me teach you another one. I'm seeing P here, so I'm remembering dash P. Dash P is another very important one. Let's clear these things. LS. Yeah, so let's do let's ls in long form. Ls dash l. Let me tell you what dash p does. Dash p preserves the time a file was created, the mode and ownership, everything. It preserves it. So you could actually copy a file into another file and preserve the time it was created. So let's walk. Let me teach you guys something that is really fun to understand and know, so you can use it. So CSS was created uh, by 1049, right? And the time currently is 1108. CSS was created by 1049. Let's say we want to copy CSS, this directory, CSS, into another directory. So cp-r, yeah, we want to add a p on it, CSS, and we want to copy it into, let's say, Greenfields CSS, right? And we've done that. It's being copied right now. So let's clear the screen and ls-l again, -l, right? So you could see that we have Greenfields CSS, and the time this file was created was 10:49. But we both know, we all know, all of us on this call right now, on this live training right now, we all know that the time is 11:09. And why this is, you could see that we have this file, Greenfields CSS here, being created at this time, which is wrong. This was when the CSS file was created. We did not create it, and we are creating it late with a prior information. So these are little things that you want to know. Little things. This is cyber security. This we have started teaching you guys little things that you need to. These things make a huge difference. Like imagine creating a file with a backdated time, right? Imagine creating a document with a backdated time. So they ask you, when did you take this picture? You could actually take a picture and backdate the time and all of that. Anyways, let me not be the one teaching you guys bad things. Um, I'll teach you guys good things. Only good things. So this cyber security, right? So you could actually do things, create files, backdate the time to a prior time that an original file was created, and it seems as though you were the one. Greenfield, it seems as though Greenfield was the one that created this file at this time, which didn't happen. So yes, we could do stuff like that. Let's go further. I'll keep teaching you guys. Anytime I remember stuff like this, I'm still gonna tell you guys. Anyways, what somebody here saying, I get the lecture very well. Okay, don't use this knowledge for fraud. I keep telling you guys, make sure that you learn this stuff and use it to build um applications that would make the world a better place, and make legal money. Okay, that's that for that. You could actually backdate the time. Like I told you guys, I could download any video in the internet and see if I post your video. If you have a video on, if you're a content creator and I post your video on social media, Facebook would not flag me for plagiarism. I don't have to edit your video. Yes, what I will do is I'm going to edit the meta information and I can actually post your video with the meta information as though it was the original content, right? So Facebook will not flag me as plagiarism. Anyways, this is just me giving you guys some information, things that you need to know about cyber security, about this. Yeah, okay. Um, Sorry about the little delay in transmission. I had to switch from, there was power failure, so I had to switch from my what do they call it? From my router to my mobile data, right? So we are still studying, we are still on the right track. Okay, can you guys hear me? Are you guys there? Right. I can see my screen, so I guess you all can see as well. So I'm seeing a restricted message somewhere. Hopefully, it's not being restricted by YouTube. I don't want them having my videos restricted. Anyways, so that's that for that. We could talk about a few more uh, flags as well. So we're talking about copying files, right? And there's another flag called dash u. Dash u only updates, it only copies when the destination file is newer, like when the file you are copying to is newer than the old the the other file, right? So that's what the dash u does. If you're copying to a folder that is newer, dash u is going to copy without any problems. But if you're copying to a file that is older, that she is going to complain and complain a lot, right? So let's test it out so we have a clear-cut understanding of what Dashu does. So we have, you could see folders being listed in long form here. We have new directory 5 and new directory 4, and we can see that new directory 5 is newer than new directory 4, right? So first of all, let's try copying new directory 5 into new directory 4 using -u. So if we do this, if we say cp-ru, we added the -u, and we want to copy new directory 5 into new directory 4, and we need to add like verbose. Let's do this in verbose mode, right? Oh, it's actually copying. Did it copy? How will we even know if it copied? Because verbose mode is just let's see. Clear ls, sorry, in long form. So ls dash l, right? So new directory 4, it actually copied, right? It copied. So we need to look for files that we actually know the difference between their contents. Yeah, file 1 and file 2. Let's use file 1 and file 2. So ls, you can see file 1 and file 2 have different contents. Let's check the contents first. Cat file 1 and cat file 2, right? So you can see that the contents are different. So which of them is newer? File 2 is obviously newer than file 1. And when I was explaining this, I said it only copies when the source file, right, is newer than the destination file, right? So it copies when the source file is newer than the destination file. So if the file that we are copying from is newer than the destination file, is going to copy. But if the file that we are copying from is older, it's not going to copy, which means if we do file 1, if we copy file 1 into file 2, right? Am I confusing myself? Let's check. So cp file 1 into file 2, ls, come on, cat file 2. I think it copied. Oh, yeah, it didn't copy. So you can see that we just copied file 1 into file 2, and the content of file 2 is, oh, it actually copied. Is the content in file 1. So I don't know. Let's check this man ls man ls and see. So we could actually always refer to the documentation, right? We could always refer to the documentation. So let's go look for -u. I know this -u. I don't know why we were not able to implement it. So -u, yeah, so this is -u. With L to sort by show time. With -l, show access time or others. Copies when source file is newer than the destination file. Well, okay, sort by show by access time. Yeah, it's supposed to sort by access time, show access time, and all of that. Okay, so I guess I'm get do not sort list alone. Okay, I guess I'm getting the flags are just so many. Can you see all of these flags? You can't carry all of them in your head, but basically, is it ls I'm checking? No, we are wrong. We are in the wrong man documentation. Is copy we are supposed to be looking at. So man copy cp, right? Yeah, so this is where we are supposed to be. So let's look for -u here. You can see that the functionalities are different, right? So you can see equivalent to update older file, right? Update, this update if the source file is older than the destination file. Anyways, you guys should go practice this. Practice how to use this -u. It's very important to avoid updating things when the source file is older or newer. So let's see, -u is to update older file. Update if the file you're updating from is newer. Okay, we can practice it, but I don't want to be practicing anything here because I have a whole lot to talk to you guys about. Let's see where you guys are. Yeah, okay, so you guys are still here. So dash u updates if the file is older. Let me clear this screen and go. We can still practice this, right? We are here together. um so we should ls with long format so we can find out. So file 1 and 2, you could see this file 2 was created, text file 2.txt was created by 11:17, and file 1 was created by 9:31. So if we last time we copied the older file into the newer file and it copied, right? So let's copy the newer file into the older file to clearly understand what they are saying. Cp dash u, copy file 2 into file 1. Still copying. Let's see, cut file 1 and cut. Oh, we had not changed the information in both files to be different information. Anyways, I'm not going to stress myself with that. Let's go further. You go play with that dash u for copying to clearly understand how dash u works. So it's another very important one. It's very important, very. Sometimes you don't want to copy things that are newer to an older file, so you don't lose things. You might want to create like a backup file first before you copy. Okay, talking about backup files, and we could actually do interactive mode and verbose mode to always see what we are copying, and then we put it in a backup file. For you to create a backup file, that's another use case of C. So basically, you want to work on file 1, right? Of this cp command, you can do file 1, and let's do dash I, interactive and verbose, and we could copy file 1. Before ever you work on a file that you know that you really need, it contains important information, you want to back it up. So you want to copy file 1 into something like a file 1 back file, right? File 1 underscore, let's say BAK for back, or BCK, anything you want to call it, .txt, right? So if you do this, it's going to say you have copied file 1 into a backup file, right? A backup file 1. Yeah, we are supposed to have file 1 here, underscore back. Yeah, so that's that. We just created a new file. Anytime you want to work on files like this, we just created a backup file for file 1, and the backup file is going to contain everything that was in file 1, right? Anytime you want to work on a file that you know contains sensitive information, this is a convention. Always have a backup for it. Very important information. Before working on a file that you know contain uh, sensitive information, always have a backup file for such a file. Yeah, so that's that for that. What else can we do? Well, you could copy recursively and also preserve. uh let's do the same thing for files. So basically, what can we do? We want to copy recursively new directory 5, and we want to preserve. Sorry, I need to add the flags. Copy recursively. We want to preserve new directory 5's time, and we want to do this in verbose mode, so it shows every single thing it's doing into new directory 6, right? And if we do this, you are seeing that it's copying new directory 5 into new directory 6, everything. So if we show new directory 5 and new directory 6 in long form, ls-l, you would see that they both have the same time and they were created at 11:04, which it's currently 11:25 at the time of this class, right? So the time is 11:25 right now, but it's still having the same time. I did it before with files, right? So I'm just showing you with folders that it's still possible, right? So let's clear the screen and go to the next agenda for the day. We have like a whole lot to talk about. Yeah, so that's that for copying. Another really important one that you need to know about is moving things around. Like if copying things, keep last time when we were copying things, everything we copied was still there, and then we saw the new file that we copied them into. But now we want to move things around, right? So for you to move things around, you you have to use an MV. We might have to have another class on Sunday as well to ensure that, because it's getting really late and I don't want to keep you guys up till 12, right? We might really need to have another class on Sunday to complete this because we have a lot to learn. We have more commands to learn and more flags, as well as what do they call it? Projects to build in the bash, right? So uh, let's talk about copying. We are trying to be fast as possible. We'll talk about a few and then we'll quit for today and continue tomorrow, right? We'll announce the time and go live. Okay, so let's talk about moving, right? We could actually move files and directories around, and it also has a few flags that could go with it. So let's move things first of all. ls, so you see what's on the screen. So if we are to move file 5, okay, we have new directory 6, right? So if we are to move new directory 6 into new directory 7, you would now realize that we need to do this recursively, as it's a directory, right? So if we are to do this, come on. Oh, we are no longer copying, right? We are not copying, so we can actually move, right? So this is one difference between MV and CP, right? See, in MV, I've been teaching you guys about CP for a while, and I was actually using recursive mode to move. You don't actually need to move recursively. I don't know why. I was hoping for it to be the same way, but it's not. That's how we saw it. So for moving, you can move new directory 6 into new directory 7. It's going to remove new directory 6 from the screen and only show new directory 7. So if we should do an ls now, you would see that in place of new directory 6, we have new directory 7. There's no new directory 6 here anymore. That's what it means. That's what moving feels like, right? So moving still have a few flags to make moving a much stronger tool, right? You could move in interactive mode, which is like it's still the same way as we did in C, in copy, right? Interactive mode would ask you before overwriting, right? So if we want to move, let's see what we have. We have new directory 7, and we no longer have new directory 6. We have new directory 5. So let's try to move new directory 7 into new directory 5, right? Let's try to move that. Oh, sorry, we moved without adding the interactive mode. So new directory 7, like you can see, we just moved new directory 7 into new directory 5, and we no longer have new directory 7. The content of new directory 7 has overwritten the content in new directory 5. So this is a very delicate command. Anytime you're using it, you have to be sure of what you are doing before you overwrite things that you don't want to overwrite. And one thing you should know, anything you don't have a backup for, you cannot retrieve in the terminal. There's no temporal storage where you could get files. So the terminal, you have to be very delicate when you're working here. So let's do the same with new directory 5 and new directory 4, but this time we are not going to forget the flag, right? So we are moving in verbose mode -I, right? New directory 5 into new directory 4, right? And is asking us, are you sure that you want to overwrite new directory 4 with the content of new directory 5? And we are going to tell it, yes, this is what we want to do. And you can see that it's complaining, hey, you cannot override the content of new directory 4 with new directory 5 because the directory is not empty, right? So that's basically how it works in folders. It's complaining that we cannot do that just because the directory is not empty. So we could have this code would have worked if this directory was empty, but it's not. So um uh I think they both have the same content, new directory 4 and new directory 5. We just copied them as well. So that's just to tell you you cannot overwrite or copy from a directory to a directory that is not empty, right? And we can force overwrite, right? This we can actually force an overwrite on a directory. How do we do that? We do that with a -F, right? So remember last time he just finished complaining to us that we cannot overwrite this file, right? So imagine that we have a -F here. Is it going to work? So let's put a Y. So you could, oh, sorry, what's it complaining about? So let's sorry, let's use files instead of directories. Let's use files to learn. File 1 and file 2, right? We have file 1 and file 2. Let's say move file1.txt into file 2. Let's say move file1.txt into file 2, and let's give it the -I, and let's force it, right? So it's moving. It has moved what the content of file 1 into file 2, right, without complaining. Let's change the content of file. Both files now have the same content. Okay, file 1 is no longer supposed to be there as well. So file 1 has been removed. It has been moved. Its content has been moved into file 2, right? So we still have the backup file for file 2. I think this backup file was created for file 2. Let's clear this screen, and uh, let's clear the screen. And can any of you hear me? Can you guys hear me? We've 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 gone far. So because of the -F, we are forcing it. We are forcing the the movement, right? Um, what else do we do? What else do we do in moving? When it comes to moving, another thing that we could do is we can say -N. -N is never overwrite an existing file. So currently we overwrote file 1 with the content of file 2 currently, right? So ls, we overwrote file 1 with the content of file 2. Let's create file 1 back. So let's cut something into file 1.txt. And what do we want to do? We want to cut uh, uh, file 1 information, right? So let's just save file 1 information into file 1 right now. and you can see that we now have file 1 and file 2, right? So now if we use a dash n and we say that we want to move with dash n, we want to move file 2 into file 1, into file 1.txt, you see that it's complaining not replacing file 1, same file 1 that we replaced before. Because of the dash n, we are telling the computer, hey, don't replace. If it's an existing file, please don't replace it, right? So let's clear the screen, right? What else do we talk about the moving? So we could actually move in verbose mode, right? We could actually move in verbose mode. So let's move the content mv, the content of file 1 into file 3, right? .txt, and this was supposed to be file 1.txt, and we want to move in verbose mode, right? Dash v. So you can see it's saying it renamed file 1 as file 3. So that's moving. So we'll no longer have the difference, like I said, between cp and mv. Mv moves entirely, removes file 1 and creates file 3. But cp leaves file 1 and it will create file 3. So you have both files with the two of them. Anyways, so that's what verbose mode does. Like, we should know verbose mode by now. So that's that for that. Anyways, there's another thing that I would like to show you guys before we move on. So we can move files, we can move all files with .txt, right? So we have file 2.txt, we have file 3.txt, and we have file backup.txt. So we can move all of them to let's say directory. We can move all these files to directory, to this folder directory here. And how do we do that? We say move uh, uh, all files. To say that, you'd say all, as all means asterisks, all files that end with txt. This is what this means. All files that end with txt, move them to dir, right? So if we check now, since we were moving, you can see that there are no files here anymore. But if we go into dir, cd dir, and ls, you will see all of them. You can see, as you can see here, these are all our files, right? They are all in dir, right? Yeah, so that's all our files in dir. Let's go further. What do we do? Let's clear the screen. Should we go learn another? I want to let you guys go very soon, but let's work on let's work on removing files and directories, right? So we have a lot of files and directories. Let's go back to cd dot dot. Sorry, I had so many cds. Cd dot dot, right? So we have a lot of directories here, and yeah, let's first of all, let's go to dir back and get our files back. So we want to move back all our files so we can see them on that page. So like I said, we'll move all .txt files, all files that end with .txt, one step backward, right? So I told you guys how to do this one step backward. Is two dots, yeah, and a directory sign, slash sign. So if we do this and we hit enter and ls, you see that we no longer have these files in this directory anymore. If we go back and we check, you see that they are now here. They are all here right now. So we can use them to learn how to remove files and how to remove folders as well. The bar has been restored, but I don't want to switch. If I should switch back to my router, uh, we would lose connection. So let's, yeah, so ls, these are all our files. We are to learn how to rename, right? So if you I say rename, how to remove files and directories, right? So we can remove files and directories recursively. For you to remove a directory, you have to have the recursive flag, right? Else you'll not be able to do that because there are many different directories in the directory. So to remove new directory 5 has subdirectory in it. So if you want to remove is rm, right? Rm for remove. And for us to remove new directory 5, if we should just do this, remove new directory 5, we are going to get a complaint, right? New directory 5 is a directory, so we cannot remove it. The only way that we can do this is by doing this recursively. So new directory 5, right? Recursively, and as you can see, it has been removed. Ls, you can see we only have new directory 4 here, no more new directory 5 that used to be here, right? So new directory 5 has gone out. To remove a file ls, you can see, let's remove our backup file, right? So we can say rm file underscore backup dot txt, and voila, we just removed our backup.txt file. Now we only have two files here when we do ls, right? And yeah, that's for that. That's that for removing files and folders. And um, we still have a few flags, right? When it comes to removing, we could still do interactive mode. Yeah, removing in interactive mode is safe for beginners, right? So let's first of all, before I do this, we have subdirectories in DRO4, right? So let's remove -r in interactive mode, DRO4. Any of them, they could be in any order. You don't have to write it. I'm just writing it this way because it looks good. I like writing things, code in such a way that it looks good. So you can see that it's asking us, do you want to remove DRO4? And we say yes. It's going to ask us, do you want to remove DRO5? We say yes. It says, do you want to remove the subdirectory that is everything in DRO4? We will keep on saying yes till we finish saying yes, right? Till it finish asking us every single subdirectory that is there. So I said yes, one after the other, right? So we've completely removed all the subdirectories inside the arrow 4. At any point, if we wanted to stop saying yes, we could just press a Control C and it will remove only, imagine we said yes for only 1, 2, 3, 4, and we want these files to still be there. We would stop saying yes and just press a Control C, and then the rest of the files. Let's just do that anyway, so you see. And you guys, I want you guys to have a strong mastery of the terminal, right? So let's use new directory tree. So remove -r and in interactive mode, right? New directory tree, right? And we remove new directory tree. We say yes here, we say yes here, and at this point we can decide to uh, uh, do a Control C, right? And we've broken out of the interactive mode remover. So you can see that ls, we still have new directory tree, and we only removed a few subdirectories inside, the first three that we were asked to remove, right? So new directory tree itself is still in our computer because we've not removed all of them the way we removed all in new directory 4, right? So that's that for that. What do I teach you guys? I've taught you guys how to remove things in interactive mode, and I've taught you how to do verbose mode. And yeah, there's another one that is fun to know. -d removes empty directories, right? So if you use a -d, it's going to remove an empty directory, and -f is to force the removal, so you don't have much. Anyways, let's just use -f, right? So rom -i rf new directory 3. Sorry, that was wrong. I had it space before the tree. So new directory 3. Yeah, so like when we use interactive mode, the system is supposed to ask us if we want to remove this, if we want to remove all the subdirectories one after the other. But because of dash F, the system is forcing it. It's just forcing remove. So if we should do an ls, you would see that we no longer have new directory 3. We ended at new directory 2, right? So the system forcefully removed the new directory 3 entirely. Are you guys there? Let me check on you guys. Hopefully I'm not talking to myself. Yeah, so we are here together, right? Yeah, so let's go on so I can let you guys go for today. I'm almost done with you guys. We've talked about removing. That's all about removing. Let's go further to anyways, I was supposed to talk about cutting right now, but I feel like I should let you guys go for today. It's getting really late. Should I do that or should I complete it? Should I talk about cuts? Because I've been cutting stuff a lot right now. I've been cutting a lot of stuff and I've not talked about what I do when I cut. Anyways, I'm going to let you guys go now because it's getting really late. I don't want to keep you guys up till 12. Getting very, very late. And we'll fix another time for the continuation of this bash tutorials, right? And we'll do that. We'll continue. We'll, complete the bash tutorials, and we will as well build a few projects on the bash shell. All right, it was nice training you guys today. I'll see you guys in the next live stream, hopefully. All right, do have a good rest of the day. Do have a great night. Sleep, go to church, serve your God tomorrow.